The process begins with the input of raw materials. In this case, Rapid Plas uses polyethylene beads as the base material for their rainwater tanks. The polyethylene beads are carefully selected for their quality and consistency. They are specifically chosen because of their excellent properties, including resistance to chemicals, UV radiation, and impact. Once the polyethylene beads are prepared, the next step is to blend colors into the material. This is an important aspect as it allows Rapid Plas to offer a variety of tank colors to suit different preferences. After the color blending is completed, the polyethylene beads undergo a heating and cooling process. The heated and cooled polyethylene beads are then ground into a fine powder. This step ensures that the material is consistent and has a smooth texture, which is crucial for the subsequent molding process. The RG Blend 20 powder, which is a proprietary blend developed by Rapid Plas, is poured into a mold. The mold is designed to give the rainwater tank its desired shape and dimensions. Once the mold is filled with the RG Blend 20 powder is sealed tightly. This step ensures that the powder remains in place and takes the form of the tank as it undergoes further processing. After the RG Blend 20 powder is poured into the mold, it is tightly sealed and transferred to an oven. Inside the oven, the powder melts and fuses together, forming a solid tank structure through controlled heating. The sealed mold is then placed into an oven. Inside the oven, controlled heating takes place, allowing the RG Blend 20 powder to melt and fuse together. After the heating process, the mold is removed from the oven and undergoes controlled cooling. This step allows the tank to solidify and attain its final shape. Once the controlled cooling process is complete, the transformation of the raw materials into a fully formed rainwater tank is finished. The tank now possesses the necessary strength and durability to withstand various weather conditions. Rapid Plas places great emphasis on quality assurance. The tanks undergo rigorous inspections to ensure that they meet the highest standards. This includes checking for any defects, irregularities, or imperfections that may compromise the tank's performance or appearance. As part of the quality assurance process, each tank undergoes a 20-point touch test. This involves carefully examining and inspecting different areas of the tank to ensure its structural integrity and overall quality. This thorough inspection guarantees that the tank is reliable and built to last. The tanks manufactured by Rapid Plas are known for their unprecedented structural integrity. The combination of high-quality raw materials, precise manufacturing processes, and stringent quality control measures ensures that the tanks can withstand even the toughest conditions. The process begins with a machine called a single phaser. In this step, a liner made from softwood tree fibers and a medium made from hardwood tree fibers are combined to form a single face web. The medium passes through corrugating rolls under high heat and pressure to create flutes, which give the corrugated board its strength and cushioning capability. Cornstarch-based adhesive is applied to the flute tips using a glue roll, and a pressure roll ensures proper bonding between the liner and medium. This combined web is known as the single-face web. In the manufacturing process of corrugated boxes, the liner and medium are essential components that are fed into the single phaser from opposite sides. Roll stands are used to hold and supply the rolls of liner and medium. To ensure uninterrupted production and seamless transitions between rolls, a splicer is employed. The splicer serves as a connecting device, allowing for the smooth transfer of paper from one roll to another without stopping the machine. This feature is particularly beneficial when there is a need to change the paper grade or width during production. When a roll is consumed or a different type of paper is required, the splicer enables quick and efficient changes, minimizing downtime and ensuring continuous manufacturing. By utilizing a splicer, the corrugated box production process can maintain its momentum, optimizing efficiency and productivity in the overall manufacturing operation. After leaving the single phaser, the single face web is elevated to a bridge, where it is carried to the double glue unit and the double backer. Before reaching these units, the web passes through heated rolls that bring it to the proper temperature for the next step. The web then enters the slitter score, which slits the board into the desired width and places scores into the board to create specific dimensions. This step ensures the corrugated board is prepared for further processing. After the slitter score, the board moves to the cut-off knife, which cuts it to precise dimensions as required for the finished corrugated sheet. The board then goes through exit rolls that eject the cut sheets onto belts, which shingle the sheets into stacks in the stacker bays. The stacker beds accumulate the sheets into stacks, and they are prepared for quality checks, strapping, and shipment. The rotary die is a crucial component in the manufacturing process of corrugated boxes. It is a specialized cutting tool used to create precise and intricate shapes on the corrugated sheet stock. The rotary die operates by pressing the cutting blades against the stock as it passes through the machine, effectively cutting out the desired shapes. The rotary die consists of two half-cylinders with metal blades embedded in them. These blades are carefully designed and positioned to match the specific box type being produced. The cutting blades can vary in size, shape, and pattern, depending on the complexity of the box design and the customer's requirements. The foam rubber sections incorporated into the rotary die serve a critical purpose. They help eject the cut board scrap pieces, ensuring smooth and efficient operation. This scrap material is collected and recycled back to a paper mill for future roll stock production, contributing to sustainability efforts in the corrugated box industry. The rotary die cutting process offers several advantages. First, it allows for high-speed production, as the cutting is performed continuously as the corrugated sheet stock moves through the machine. Moreover, the rotary die cutter provides versatility in box design. It can accommodate a wide range of shapes, sizes, and intricate patterns. This flexibility makes it suitable for various applications, including custom packaging, retail displays, and promotional materials. Additionally, the rotary die cutting process ensures accuracy and precision in box production. The cutting blades are carefully positioned and maintained to deliver consistent and high-quality results, meeting the strict specifications and tolerances required for corrugated boxes. In the rotary die cutter machine, designs and branding are printed on the bottom of the corrugated sheets as they pass through the print section. After printing, the sheets reach the rotary die cutters. These cutters, made of two half-cylinders with embedded metal blades and foam rubber sections, cut the boards into specific shapes and remove the excess material. The scrap pieces are collected for recycling. The sheets then go through a scrubber to remove any remaining loose cutouts and rough edges. The flexo process in the manufacturing of corrugated boxes closely resembles the rotary die cutter process until the printing stage. However, in the flexo machine, there is a notable difference in how the printing is executed. Instead of printing on the bottom of the corrugated sheet stock, the flexo machine prints on the top side. Consequently, the stock must be inverted to ensure proper printing. To achieve this inversion, the stock is transferred to a pre-feeder, where stacks of sheets are automatically inverted. This automated process eliminates the need for manual inversion, enhancing efficiency and reducing the potential for errors. Once inverted, the sheets are shingled and loaded into a feed bed for further processing. In the flexo machine, print plates are mounted on a cylinder. These plates contain the desired designs and branding that will be applied to the corrugated sheets. An ink system is employed to apply ink to the print plates, which is then transferred onto the sheets as they pass through the machine. The cylinder with the print plates rotates, ensuring that the ink is correctly transferred onto the top side of the sheets. Similar to the rotary die cutter process, the flexo machine also employs rotary die cuts to cut the sheets into specific shapes and dimensions. The cutters used in the flexo machine are customized based on the box types produced by the factory. The blades embedded in the rotary die cuts through the sheets, creating precise and clean cuts, according to the specified box designs. After the sheets have been printed and cut, the resulting boxes are carried through a folding section with the assistance of vacuum-assisted belts and folding rods. This process ensures that the panels of the boxes fold in the proper sequence, creating well-formed and functional boxes. The folded boxes are then glued and joined as they exit the machine, and they are stacked into bundles according to customer specifications. The Flexo process offers versatility and flexibility in box production, allowing for various designs and customizations.